Okay, here we are on the next stop on the Grand Canyon South Rim field trip. Here we're going to spend some time within the canyon. We're going to hike down the South Kaibab Trail, up the North Kaibab Trail a bit, explore the Clear Creek Trail, and then come out of the canyon on the Bright Angel Trail. And we're really going to see almost everything the Grand Canyon has to offer. Lots of looks at the Paleozoic sequence. Some supergroup rocks are really nicely exposed along all these trails. We're going to put our fingers on the Proterozoic basement rocks, find a nice outcrop of the Great Unconformity, and a number of interesting sedimentary structures that I'll show you. So where are we? Let's zoom in on roughly this area. So here's the main visitor center and campground, etc. You can see that in satellite view. We're going to hike down the trail, starting from approximately here near Yaqui Point, the start of the South Kaibab Trail. And you can even see the trail in satellite view here. It's this faint white line there. So we're going to hike down the South Kaibab Trail along this ridge, stop here at what's called Ua Point, continue down the ridge this way to Skeleton Point, another mile or so down to the tip-off, it's called, and then the last bit of the trail descends down many switchbacks down to the Colorado River, where we're going to cross the Black Bridge. You can see it faintly there. It's a black bridge, called that because it's black. Cross the river, follow the trail a bit up the start of the Bright Angel Canyon to the Bright Angel Campground. See some images of that. Spend some time exploring up the North Kaibab Trail, which heads up Bright Angel Creek here. Also spend some time coming back down this trail and up the Clear Creek Trail up to a viewpoint approximately there. Come back down the Clear Creek Trail. And then hike out of the canyon by way of the Bright Angel Trail and Indian Garden. So we'll come back down Bright Angel Canyon, cross the river on the Silver Bridge here, follow the trail along the river, some switchbacks up this canyon here, finally, and stop at Indian Garden, which is there. We'll also spend some time exploring the area, follow this trail out to Plateau Point here, and then back up the trail. This is called the Tonto Trail, and then spend some time exploring down this side canyon, take some images from there. And then the hike out will leave from Indian Garden up the Bright Angel Trail, these switchbacks, back up to the Bright Angel Trailhead. In terms of geology, we'll be seeing almost everything the Grand Canyon has to offer. The hike starts here, approximately here from near Yaqui Point, follows down through the Paleozoic sequence. These are all Paleozoic rocks, until we reach the tip-off, which is that point there. And from there, the trail descends in the Proterozoic basement rocks, the Vishnu schist and granites. Across the river, we're still in the Proterozoic basement rocks, including a ways up the North Kaibab Trail. This will take you to the North Rim, by the way. We don't go nearly that far in this particular hike. Our hike out, we cross the river again, stay in the Proterozoic rocks for quite a while, until we follow the Bright Angel Trail up the canyon, up to Indian Garden, where we'll be in the lower part of the Proterozoic sequence. Head out along the Plateau Point Trail, which sits just on top of the Tapete Sandstone. And similarly, our hike along the Tonto Trail down this unnamed side canyon will be mostly in the Bright Angel Shale and Tapete Sandstone. Then our hike back out from Indian Garden to the rim will be entirely in the Paleozoic sequence, from the Muav Limestone approximately all the way up to the Kaibab Limestone to the trailhead. So what I'm going to show you here is just a sample of the images that you'll be seeing in the following links. There's a number of many images that I've put together in different pieces representing different parts of the hike that you can look at will. But let me just show you some of them to give you a flavor of the kind of things you're going to be looking at. So some of the images like that on the left are just as they are. Some of them, like the one on the right, I've annotated just to give you some sense of what's going on there. For example, what we're seeing here on the right, this is the Toro Weep Formation, which is a sandy limestone. More sand content in the eastern part of the canyon, more limestone content in the western part of the canyon. We're in the middle, so it's a mixture of kind of sand and limestone content. But the toro wheat was deposited during periods of small sea level rises and falls. But when sea level fell, some areas had significant evaporite deposits, such as this kind of whitish stuff here, which is often halite or gypsum and sometimes mixed together. And when that stuff is then buried by overlying sediment, the pressure on those evaporite deposits causes it to behave like a very slow-moving fluid, and the pressure causes that fluid to flow, causes those evaporite deposits to flow, and to try to find a way to relieve that pressure. In some cases, it actually deforms the overlying sediment and causes these kind of push-up structures. So there's an example of an annotated image. There's also a number of panoramas, some annotated, some not. This is taken from Ooh-Ah Point. It's named that because when you get there, you say ooh-ah, or so I'm told. Here's a great example of the Coconino sandstone, cross-bedded. The Coconino is a deposit of wind-blown sands, essentially sand dunes that became solidified. And these cross-beds, as you can see here, these cross-beds are then truncated by this line. The next sand dune deposit on top of it are very characteristic of wind-blown sand dune deposits. Here we have a great example of trace fossils. Not a fossil of the creature itself, but evidence of its existence. These are worm burrows in the Muev limestone. You can also find this abundant in the BrightAngel shale. Both of these are Cambrian sediments which reflect the Cambrian explosion, the big increase in diversity and number of life on Earth starting at around 540 million years ago. Some interesting sedimentary structures such as ripple marks. The Shinumo sandstone is a near marine sandstone, so sand that was deposited by a river somewhere near the coastline. And so these ripple marks, you can kind of see the crest of one here. There's another one here. There's another one here. Reflect the fact that this sand was moved by moving water, as in a river. A number of images just kind of looking up and down the canyon. This is the Colorado River, of course. This is the Silver Bridge, which we'll cross on the way out. This is the Proterozoic Metamorphic Suite, and here's the Proterozoic Grand Canyon Supergroup. And above it, up here, is the Paleozoic sequence. So down at the bottom of the South Kaibab Trail, it leads you up BrightAngel Creek, which is this one here, to the BrightAngel Campground, where you can camp. And there's a lodge down there, believe it or not, called Phantom Ranch. You can get a very nice meal, you can have a hot shower, and you can stay the night in the cabin if you'd like to. Take a quick walk up, a day hike up the North Kaibab Trail, which you walk far enough, takes you all the way to the North Rim, to take a look at some really great metamorphic structures. We're kind of in the heart of the metamorphic sequence in the Grand Canyon, and you can really see how these rocks were highly deformed when they were formed. And so there's lots of foliated rocks. This dark stuff is nearly vertically foliated. These minerals are all lined up, and sometimes it's almost perfectly vertical, as on the left, and sometimes it's kind of tilted over, giving you a sense of how these rocks are twisted and deformed. So this is a large scale version of that. You can see this a smaller scale version here too, and how these igneous intrusions were twisted and contorted as these rocks were squeezed and metamorphosed. Another great example of how sometimes there's almost continuous foliated metamorphic rock. This rock is schist. Sometimes these igneous intrusions like these are relatively small. These are just 6 to 9 inches wide or so, but sometimes they're really quite large, and it just depends on where you are, the proportion of igneous to metamorphic rock. Here's a great look back from the Clear Creek Trail from where we came. This is the South Kaibab Trail, which we hiked down to get to the river. The river's flowing that way. So our hike out, we cross from the other side of the river, cross over the Silver Bridge, and then we're going to follow the BrightAngel Trail off to our left towards Indian Garden. There's a number of old faults down near the river, which have displaced both the basement rock on the left, and in this case also the Grand Canyon Supergroup rocks these sediments here, which have moved down relative to the basement rocks, which really kind of hid them from erosion, allowed them a place to hide and prevent this particular package of rocks of being eroded, where in most places in the western part of the canyon here, the supergroup has been entirely eroded away. Stop along Pipe Creek quickly to have a look. Hike up Pipe Creek Canyon for a bit, which again has another great exposure, some really gnarly looking metamorphic textures. There's some interesting culture there. There's some old mine shafts of people who have, back in the 1800s try to make a small living mining for mineral resources. They were unsuccessful in this particular spot anyway. But it's some interesting culture along this trail. We're going to stop and take another look at the Great Unconformity. Here it is. This is the Tapete Sandstone, which is early to middle Cambrian. Here we have the Vishnu Schist on the bottom. And the line in between this unconformity in this part of the canyon is about 1.2 billion years. This is a nonconformity where you have sedimentary rocks overlying igneous and metamorphic rocks. In the eastern part of the canyon, we've seen the Great Unconformity as an angular unconformity, but here, the supergroup rocks have all been eroded away, and we have the Paleozoic rocks deposited directly on top of the Proterozoic basement, making it a nonconformity. And here's the up-close and personal version of it, where we have the Paleozoic tapetes sitting on top of this fairly flat line, and here it's about 1.2 billion years of missing time. We take a walk down a side canyon, an unnamed side canyon, which goes down primarily through the Tapete Sandstone. That's what this stuff is here. And so we're going to follow this canyon down towards the river. This is what it looks like looking back up the canyon. Again, Tapete Sandstone. And we're standing more or less on the top of the Vishnu basement rocks. Oops. But down at the bottom, there's an interesting sight. There's a rafting and kayaking party that I saw as they were traveling through this part of canyon off to the left. So I found some cool fossils, some trilobite fossils in the Tapete Sandstone. There's a number of them, as you can see here, and up close, this is what they look like. Also found some interesting ripple marks. The Tapete Sandstone is a beach deposit, deposited in a near shoreline environment, similar to the Shinumo sandstone, and these ripple marks illustrate how this sand was transported by moving water towards the beach. There's another outcrop of the Great Unconformity. This is the Tapetes. The Tapetes is sometimes purple, sometimes it's white. Here it's purple. Below it is the Vishnu Schist. It's been heavily weathered, but nonetheless, there's another example of the 1.2 billion years of missing time of this particular part of the canyon. Here's a view from Plateau Point. Really spectacular view of geology and the canyon itself. All right, finally we're going to hike out of the canyon up the Bright Angel Trail, which we're standing right near Indian Gardens, which is about halfway from the river, and we're going to follow the trail up, and it switchbacks somewhere in here and then finishes in the trailhead, which is approximately there. Great looks at the Paleozoic sequence. We're standing on the top of the Redwall limestone approximately, and we're about to hike up through the Supai group here, which is overlain by the Hermit Shale, which we can't really see from here, cross through the Coconino Sandstone, which is this, Taro Weep above it, and then finish with the SKaibab limestone layer on the top. Look backwards from about 2/3 of the way up. Here's Indian Garden. The finish of the hike is behind us. Just a great view of the area and to see where we came from. This is what a traffic jam looks like on a Grand Canyon trail. All of the trail maintenance is done by mule, and so this day these guys were hauling buckets of dirt down onto the trail and spreading it around by mule. And the rule is on the Grand Canyon trails, when the mules come by, the people have to step aside. Or if the mules are standing in the trail, everybody just waits, because the mules are fairly tame and they know their jobs, but they're not completely comfortable with having a lot of people walk by them. So when the mules stop, everybody stops. Finally, last one. This is just a spectacular view looking to the north of Bright Angel Canyon Here we are along the Bright Angel Trail. It extends through Bright Angel Canyon, which is off this way. We're standing in this canyon. This canyon exists because these rocks have been eroded. They've been eroded because this is a fault zone, and fault zone rocks are easier to erode. So many of the canyons, nearly all of the canyons in the Grand Canyon, are defined by faults. The Bright Angel Fault is originally started as a Proterozoic normal fault, very similar to the Butte Fault. It's one of the few that was not reactivated during the compression of the U.S. during the Laramide orogeny, but it was again reactivated during more recent phase of extension, the Basin and Range extension, and we can see evidence of that here. Notice the difference in elevation between the top of the Red Wall limestone on the left and the top of the Red Wall limestone on the right. The left side has been uplifted relative to the right, and that uplift has happened relatively recently in the past 20 million years or so. All right, thanks for listening. Go take a look at the images for yourself, and I'll see you at the next stop.